Okay, so I gave the kids this number and that angle, and they were able to figure out that this would be negative 7 over root 2, as in this and this direction, because they're the same. So it would be negative 7 over root 2. There are some kids that really like rationalizing, so they would have multiplied by root 2 over root 2, and you'd have gotten 7 root 2 over 2. That would have worked. And I could say plus negative I 7 over root 2. So it's the same exact number, it just has to have an I on it. Now, plus minus does mean the same thing as minus, so you don't have to have the plus minus. You could just say minus. And there you go. There would be rectangular form of this complex number. Yes? Good question. This I does not have to be in front. Usually I put it in front, but if you put it there, you're fine. The reason I don't like to put it after is, let's say you had a root 2 and then you have this. People question whether the I is under the root or not. And that's why we often put the I in front of our answer, because then it won't stray underneath a root. So it's totally okay to have the I after it. Okay, and then the complex polar. 7 cis. And then what's this angle? Pi over 4. I could see you could say on that, but being completely wrong. Instead, it's supposed to be this angle, which would be negative 3 pi over 4. Raise your hand if you had that one right. Almost everybody. Nice work. Okay. Then, how do we start this whole unit? Do you remember? It's been a while. This is our 6th day of it. Well, do you remember that something like this, to solve it, you could factor it or you could use the quadratic formula? What happens if you're in the middle of doing a quadratic formula, but it's got a square root of a negative involved? Then what happens?
Cry.
Don't cry. No, cry. No reason to cry. When you have that square root of... Oh, hello. What is this?
What? Someone's having a birthday.
Oh, wow. That is amazing. It must be nice to have a mom in the building. Happy birthday. All right. Oh, go ahead. Sing it for her. Go ahead. If you're going to sing it, you guys got to do it, because I'm never going to remember everybody's birthday. So this is somebody else doing this, not me. All right. All right. I'll pause. So, if you had this one, you should know how to factor it like that. But that would be a little easy because the answers are both real. What's special about this unit? What's it called? Complex numbers. These aren't complex. They're just 1 and -1. But at least, -1 and -2. And at least you'll remember then that -2 isn't a factor. That's the factor. That's the what? The root, the solution. Okay? So what if I said one of the roots was I? Tell me what the equation must be. If one of the roots is I, then hint, you should know what one of the factors is. And then you should know stuff about imaginary numbers that causes you to be able to write the equation. I'll say it one more time. The root is I. Write an equation that could be the answer. There is more than one right answer. Okay, so if I is the root, how many of you figured out x minus I must be the factor? All right. You remember me saying x minus Bob? It doesn't matter what the root is. If the root is Bob, then it's x minus Bob. So it's just always x minus whatever it is. Okay, so then who also knew that there was another one that had to be in there? Ooh, a lot of people remembered, but not everybody. X plus I. If you didn't remember that, remember it, make yourself remember it by writing it down right now and multiply it out, because then you'll have the equation. I know, this is an equation too, but I want you to see what it looks like when it's not in factored form. X times x, etc. Oh, those cancel each other. That's kind of cool. That's because these are what's that called again? Conjugates. Yes. And these guys cancel, and so then the answer has minus I squared in it, and so the final answer is x squared minus I squared. True or false? False. Why? Because I squared is -1, which multiplies by the other negative and makes it x squared plus 1. There's your equation. Okay, now I'm going to make something similar to that. Do you remember starting this unit with factoring, including like the long division and all that stuff? It's been a while since we talked about all that. Let's see if you can factor that. Factor this, including factoring it over the complex numbers. Meaning, if you haven't factored it until you got an I, you haven't factored it all the way. So today is kind of our shorter of the 2 review days, but I'm going to cover everything today and go back and just hit a few highlights tomorrow as we also grade the lab. And then the next day is the test. So again, current plan, test Friday. Today we review pretty much everything. It's going to be a long review day with just a few find the 3/3 roots kind of problems as your homework. And then tomorrow, a little bit of wrap up review and a lot of grade the lab. It won't take that long, but we'll get it done and in the grade book. And then Friday's the test. Okay, in case you forgot, this kind can be factored this way. What comes out of these two? X squared does. What comes out of these two? Well, nothing does. Well, then it always 1 would. So you factor a 1 out. Why do you do that? So that when you see that there's an x plus 1 in both parts, and you pull those out to the front, you can take what's left and put it in here. And you might feel all proud of yourself, but you'd get it marked wrong. You know why? Because it isn't factored over the complex numbers. That's the whole point, right? You could have done this last year, but here's what you wouldn't have been expected to do last year. You wouldn't have been expected to know that that's x plus I and x minus I. I did mention it last year because I knew that someday you'd be sitting right there and you'd be just a little bit smarter, and it would. I cheated you out of learning it this year by teaching it to you last year. All right. So imagine for a moment you get done factoring something and it looks like this. You're going to be tempted to quit because you factored it over the real numbers. But you're going to want to factor it the rest of the way. Factor it over the complex numbers. So then, do you get that wouldn't work, because this part here would make x squared plus 4x plus 4. So what's the little tweak I need? An I, and now it'll work, because that'll make the extra I squared we need to change the sign on it. And wait a minute, now not even that is exactly right. Something's wrong, because I'd end up with a -4. I don't want a -4. 1 minus and 1 plus. So there we go. X plus I, 2i, x minus 2i, and then an x plus 5. That's factored over the real and complex numbers. Yes. Oh, you're right. Thank you. Good catch. There's supposed to be a minus here. Thank you. Okay. Would it have been safe to say that this polynomial had a root of 2i? And then automatically you would have known that would have had a root of what? Negative 2i. All right. Okay. Next, let's talk about that 3/3 roots thing. The key to it was you had to remember to add plus 2 pi k at just the right moment. Let's see if you remember. Square root of 3 plus, I'm going to get minus I. Would you agree that that's a complex number? Because it has a real part and an imaginary part? Okay. Now, could we graph it in the complex number plane, the x, y, I plane? Sure. And you might even be able to say, it's kind of like African or European swallow. You could say something like, would you want it in polar complex or would you want it in rectangular complex? I'd like you to graph it and tell me what it is in polar complex. Once you make the picture, I'd start with rectangular, and then I'd be able to convert it over to polar pretty easy. And pause for a second. Okay. The red line is root 3. The green line is negative 1 in the I direction, because this is the YI plane, and that's the X. I shouldn't say plane, the axis. And then I have to now figure out how long this side is. Ooh, I know this one, 1, 2, root 3. So this one is 2 cis. And I can sometimes put a little plus in there to remind you it actually means cosine plus what? I sine. Okay, good. And making sure I didn't screw anything up here. 2 cis, and then I need an angle. That's probably a 30-degree angle. And there's so many places you could mess up. What'd I do wrong? Negative pi over 6. Okay, awesome. Okay, cool. 2 cis, negative pi over 6. Now, what if I wanted to know what that was to the third? The reason I didn't use squared is because squaring it, you could just, this times this, you could just write out 2 of them and multiply it out. But to the third, you're going to have to know de mauve. De mauve. Pausing for a moment. Okay, so we did to the third power. We put that 3 down here and there, and that's an 8 cis negative 3 pi over 6. But anybody simplify it? Pi over 2. Good. All right, so negative pi over 2, yes. All right, so final answer is that. Now, how would it have been different if I'd asked you to do the 1/3 power? Got an answer, sir? Okay. How would it have been different if I'd asked for the 1/3 power? Would it be different? Yes, a lot different. A lot more steps. So here's how it would kind of look. I'm going to change the problem completely. Notice I switched them around so it's not the same cis. Okay, find cis form for it. And then if I say z equals this, and then I say z to the third equals that, then if you want to solve for z, you'd have to put both sides to the what? To the 1/3 power. And then you'd be finding the 3/3 roots of this complex number. I'm going to pause for a second while you give that a try. What's the umbrella from? Ah. Oh, it's that one. Interesting. I hope you'd be smart enough not to write this out 3 times and multiply it all out. Instead, you changed it to cis form, right? I'm going to make a picture for it just because it makes the most sense to me if I see it in a picture. That's 1. That's square root of 3. Means that must be 2. And now I know this one. It's the 1, 2, root 3. This is 30, 69 triangle. This is 2 cis pi over 3. And I'm going to now put it plus, hold on, 2 pi k. then it's all to the 1/3. And then I drop the 1/3 power onto this, and that. And then I have 2 to the 1/3 cis pi over 9 plus 2 pi k over 3. Will that one drop out? It's kind of a trick question. Will this drop out? Sometimes yes. When would it drop out? If k equaled 0. So the first one you do is k equals 0, and that drops out. 2 to the 1/3 power, yeah, I got to keep dragging it around unless you want to go find the in decimal it goes on forever. No. So you're probably going to leave it as 2 to the 1/3. Cis pi over 9. Yay, I got my first answer. K equals 1. I stick in a 1 right here. And then I got to add 2 pi over 3. No, I don't. I want to add times by 3 times by 3, 6 pi over 9. And then once I realize that trick, I just have to keep adding 6 pi over 9. So this will be 7 pi over 9. This one will be, I don't even have to go through the whole stick the 2 in here. I can save a whole bunch of time and just remember, oh, add 6 pi over 9. 2 to the 1/3 cis 13 pi over 9. And then I'd cry a little and mark it part wrong. Because at what moment did you just break the law? Yeah. You can't have 9 pi over 9. Well, 9 pi over 9 you can have. But we went past what we can have. Then the next logical thing to know is that 18 pi over 9 would be 2 pi. Why do you care about that? Because if you're trying to figure out where you are, 13 pi over 9 is here. And this was 9 pi over 9. And this would be 18 pi over 9. And we're partway here. How much more to get to 18? That's my way of figuring these out. 5 more to get there. So 5 pi over 9, except it's got to be negative because we're going to go this way. Negative 5 pi over 9. All right. What could we have just done? How can we get this to always just like a nice simple thing we could do to get that number? I always have to draw this picture. Can you think of a simple way to change 13 pi over 9 into negative 5 pi over 9? Do you have a simple way? Yes. Yes, but the 18 is not like super intuitive. I agree with you. Yep. There you go. Yep. If you want to remember a weird formula, double the denominator and subtract it from that. That would work. I think probably since we're using pictures for everything else, picture approach is probably the best way to go. Just okay, so are you saying we could take 13 pi over 9 and subtract 9? 13 minus 9 isn't... 4 pi over 9 is not the same as negative 5 pi over 9. I'm so confused. I'm sure that makes sense to you, but it doesn't make sense to me. All right, so here's our 3 answers. We needed 3/3 roots, we got them. Okay, that's one of the tougher things, especially if you have to convert those. If they go over pi, you got to convert them. Okay. What else do you have to know? Oh, so many things. Now remember, I'm covering everything today. So, everything is a strong word. Everything I'm going to cover is going to happen today. And then tomorrow I'll redo a few of the most, like, ones that people get wrong the most. All right, so if I said I had Z, that's a good one. I is not a great name for these. I think you probably know why. And I'm going to use R. No, R is a bad name because that stands for like radius. So I'm going to use P is equal to 1 plus I. If I just asked you to multiply them, can't I just go 2 plus I times 1 plus I? Yeah, I can. All right. What if they were in cis form? What if I said like 4 cis pi over 4 and 3 cis pi? What if I asked you to multiply them then? Can you just multiply all the numbers together? 4 times 3 is 12. Pi over 4 times pi is pi squared over... no, that's not going to work. So what do? Do you remember? Don't say it. Try it. Write down what you think this one is. The top one would be a little too easy because you just would multiply them together and you'd end up with an I squared, and then that would be -1. I know you could handle that. Pausing for a second. 4 times 3, 12. Cis pi over 4, pi. Oh, what do I do in this kind? Multiply goes with add. So, but wouldn't it be smarter to add 4 pi over 4? Yep, because then I got a common denominator, 5 pi over 4. All right. Oh, mistake? I think that's right. Oh, wait, you got me. What is it? You can't say 5 pi over 4. It went past what? Past pi, so I can't do that. All right. So I've changed this to, well, that might be stretching it, negative pi over 4. One more thing. Would we ever leave this as a negative? No, and one more little thing. Uh-oh, hold on. All right, I'm blaming you for this. Negative 3 pi over 4.
How would you blame me for?
All right, it's physically challenged. 12 cis negative 3 pi over 4. There's supposed to be a negative in here. And I don't think anybody can think anymore because it smells like cupcake everywhere. I'm going to pause for it. Okay, while you're finishing off the leftovers of your brownie, think for a second of what you would do if I asked you to do that times that. Do you remember what that means? 12-minute warning. It's not just z times p. What does the with a line over it mean? Conjugate. So what is the conjugate of... What is the conjugate? Gentlemen, I use that term loosely. There was 2 guys talking, but anyway, you were making the most noise. Can you tell me what the z with the line over it means in this case? Too late. 2 minus I. No, because it's the conjugate of this. Okay, and then times p, which is 1 plus I. Do I have to go through all the work to change those over to cis form? Nope. You can just plain old-fashioned multiply them out. And at some point, an I squared will appear, and then you're going to change it to a -1. Give that one a shot. If you wish, you can change it to cis form and multiply it all the way out. You can do that. If they asked for the answer in polar complex form, then I probably would change it to cis, because you have to do it anyways to get polar complex. If they wanted rectangular, I'd definitely leave it alone. Those 2 together just make an I. What is minus I squared? Well, what is minus -1? So it's +1 plus the 2 makes 3 plus I. Raise your hand if you had 3 plus I. You can do math. Okay. So that's complex numbers and using either add, subtract, multiply, or divide. If you ever have to put it to a power, what if I'd have said that squared? Then you probably would have wanted to go to complex form after you've done the modulus, sorry. After you've done the conjugate, then you'd probably want to do the de Moivre thing. Okay, so let's just do one like that, and that's going to be, would you please figure out what conjugate of p squared would be. And since p is 1 plus I, you might want to make that polar complex. Now, since we have to do modulus, no, keep saying modulus. It's not modulus. That is, I think the sugar in the pastry is messing with my brain. That is called the conjugate. Oh, we have to do the conjugate of this. So that means I have to do 1 minus I, then make it into polar. 1, positive 1, minus 1I. So then this is 1 root 2, and so then it's root 2 cis. And since I'm down here, negative pi over 4. Hopefully you're with me so far. And then I just have to square it. So then I square it. Some of you are like, why did you change it to minus? Because this little line here is saying you should do the conjugate of it. We always start inside the parentheses, right? So there, I changed it to its conjugate. Just in case you forgot what the modulus is just this. That's another name for R, is the modulus. When we're in polar, it's for sure called R. When you're in polar complex, they change it to being called modulus. That is called a modulus when you're in polar complex. I like to just keep calling it R. The only reason that it ever matters at all is, do you remember me saying you can't have negative R's during this unit? Because you can't have a negative radius in this unit. You could before. Back when we were in polar, you could have negative R's. But not when you're doing complex numbers. So they make a new name for it. Instead of just calling it R, they call it the modulus. And the rule for the modulus is a modulus can never be negative. R's actually can be negative. So they give it a new name. And technically, I should have been calling it the modulus the whole time. But, okay. But it acts like an R. It's just always positive. That's all. Yes. And you want to hear something about the Easter Bunny? So now we need to move on to one last kind of like zone of problems. We've talked about the kind where you have to factor things. Hopefully you remember what cosine I sine even means. I did do this in another class. Maybe I should do this once with you. Here's a really nice simple one. 2 cis pi over 6. Do you know that cis actually means cosine I sine? We really don't use it too much because we can get by with pictures. Okay, but some people teach it this way where you don't actually ever even use a picture. You multiply out 2 times cosine plus I sine. I'd like you to just do it once because you may need to know how to do that. You might be like, well, can't I just always draw a picture? Well, there's always ways to make it so you can't draw a picture. But you could do this. Use the fact that cis means cosine I sine. And multiply this out and see what happens. It is cosine plus I sine. You are correct. Pause for a second. Let me try that. So I know some people got this far. And they were like, well, how am I supposed to do that? I don't know what the cosine of pi over 6 is. Well, do you know what the cosine of 30 is? And if you don't know that, then you know this. And you should be able to know what the cosine of pi over 6 is from that, which is root 3 over 2. And then plus I times the other one, which is sine, which is opposite over hypotenuse. Oh, it's the 39th time that's come up. I sine of 30 is 1/2. I knew that one. All right, so there we go. Now, if I actually multiply this out, the 2 times this and the 2's will cancel, root 3. The 2 times this and the 2's will cancel, plus I. And look at that. That's rectangular form. So you can use the cis thing to make it into rectangular. All right. So I know you're trying to make the point that the class is almost over, but you do want to probably know what your homework is. So here is where your homework is. There are 3 questions. They are all find the 3/3 roots of whatever. And that is probably one of the hardest things that you have to know for the test, so it's a good idea to practice it. So there's 2 of your homework problems. The 3 cube roots? What? That's the same as 3/3 roots. And then, wait a minute, that's a weird one. It doesn't even have a number. It doesn't have like a normal number. Well, then it's 0 minus 8i if that bothers you. Okay, and then there's the 5/5 roots of the same exact thing. That's kind of cool because once you found cis form of it, you know, be the same. And then last but not least, the 9/9 roots of -1. You need to practice this. Another reason, there's another new lab about to be assigned tomorrow. Besides grading one, we also assign a new one. And it's about this. So you might want to practice this so that you're good at it. Okay, unless it's your birthday or something. All right, that's all I have for you for today.